Good morning. Welcome to our today's GATE session. I am Dr.G.DEEPANA from Department of Civil Engineering, S.A.E.C Engineering College. Today we are going to see about soil mechanics. This is given in a chapter section 3 of GATE syllabus, which in soil mechanics we are going to discuss two subjects which will be a major subject, which is soil mechanics and geotechnical engineering. And the geotechnical engineering we will be seeing about foundation engineering. In soil mechanics and foundation engineering, they will be combinedly asking about 5 to 6 questions, which will be a major part in this GATE examination. And in soil mechanics, there are three-phase system and phase relationships along with the index properties and unified and soil classification, how the soils are classified according to the soils classifications, how we can able to identify a particular type of soil. These are all will be coming into this syllabus, and according to that then we will be having permeability and one-dimensional and seepage flow. Along with that we will be having two-dimensional flow which includes flows, flow nets, upliftments and pressure piping. After that we will be discussing about compaction, one-dimensional compaction, and similarly consolidation, which is the reduction in the volume of water. And finally we will be discussing about shear strength, Mohs circles, and etc. And I would like to start with the quote, which is the most effective way to do this is to do it. Which if we are planning to do a work, we have to do it, and we need to start with what we are want. And coming to the introduction of soil mechanics is a branch of engineering which is dealing with the behavior of a soil particles. This soil particle will be understand based on the persons who are dealing with it. If I am an agriculturist, I will see the soil as a vegetative material, which if I sow a seed into it, it will grow into a tree, whether the soil is fertile or not. This is what I will be seeing as soil as an agriculturist. If I am a geologist, I will see that particle, whether it is a coarse grain particle or else a fine grain particle, which formation it is made of. It can be it can be a granite, or it can be a sedimentary rock, or else a metamorphic rock. According to the formation of this rock, I will be dealing with the soil. If I am a structural engineer or else a foundation engineer, I will be seeing that soil as a bearing material, which if I am a structural engineer, my structure before the soil, which is my superstructure, need to be the loads from the superstructure which will be transferred to the substructure. That substructure must be in has bare capacity to hold the strength which is from the transfer from the upper superstructure to the substructure. And what is soil mechanics? The term soil mechanics has been coined by Carl Terzaghi in 1925. According to this, he is the father of the soil mechanics, and according to his, soil is a behavior of a material in which the behavior determines its engineering properties, which will be mainly focused on what it is dealing with civil engineering, which is we will be seeing about permeability, shear strength, capillarity, and along with it we will be dealing with seepage and bearing capacity also. And first we need to know what is soil and how soil it is formed. Initially, soils are formed from rocks. These rocks can be an origin of volcanic rocks, or else which is igneous rocks, sedimentary rocks, or else metamorphic rocks. Volcanic or igneous rocks are formed from eruption of volcanoes, and sedimentary rocks are composed of sediments which is sedimented year by year. After this, a layer of rocks has been formed. This rocks is called as sedimentary rocks. And coming to the metamorphic rocks, the properties of igneous and sedimentary rocks, if my properties is changed either by physical weathering or else by chemical weathering, if my property is changed, then it will be called as metamorphic rocks. Example of igneous rocks will be granite, and sedimentary rock will be sandstone or limestone, and metamorphic rocks is a marble. And this is how the soil is formed. Initially we will be having a rock. If there is any change due to a temperature, pressure, or else rain, due to the rainfall, the erosion of a rock happens, and that erosion soils are formed. If my soil is formed soil resides in the parent rock itself. If this is my rock and this is my parent rock, and my soil produced lays in where the soil is originated, that soil is called as residual soil. If my soil which is created, if due to temperature, or else it may be transferred from one place to one place through wind, or else through water, or else through river, or it may be through glaciers. If it transports from one place to another place, then it will be called as transported soil. And according to the weathering of the soil, if it is a physical weathering or else chemical weathering. Physical weathering can be due to temperature and pressure changes, and chemical weathering may be due to oxidation, hydration, or hydrolysis, like that. If my rock happens due to physical weathering, that particle will be a cohesionless soil, which means the particle won't be stick one to one another. It will be separate particles. And if my particles is due to chemical alteration or is due to chemical other changes and due to chemical weathering, that particle is called as cohesive soil, which means the soil will be having a capacity of holding it together one another. And this is a phase diagram. While we dealing with the solid mechanics or else fluid mechanics, we will be dealing with only one nature of matter, which is it will be a solid, or we will consider it as a fluid. Okay, even though it is an RC, we will consider it as a concrete material, which is a solid particle. It is not subjected to any other phases of diagram. But while we coming into the soil mechanics, we will be dealing with three kinds of phases, which is in soil, the solid will be soil particles, which is soil solids, and after that in that soil solids we will be having some voids. In that void can be the voids can be filled with air voids or else with water voids. These both voids can be present, so that we will be dealing with three major phases. One is solid particles, and another is water, and another one is air, so that we will be dealing with three particles. This voids, which means if my voids is filled with water or else filled with voids, if my entire voids is filled with water, then it is called as saturated soil. If my voids is entirely filled with air, which means it is a dry soil. And this is a three-phase diagram which I explained earlier, and this is a total volume of soil, and in the soil we will be having some solid particles. Along with the solid particles we will be having such kind of holes. In this, the holes are present, whereas this fine space here present or called as voids. This voids can be filled with air or else water. If my voids are filled entirely with water particle, then it is called as water voids. If my voids is filled with air, then it is called as air voids. If entire voids, we will represent this whole volume as V, and if my solid particles is represented as volume of solids, and this is volume of water, and this is volume of air. Okay, this is represented in terms of volume. We can similarly we can represent this in terms of weight. This is weight of air, this is weight of water, and this is weight of solids, whereas weight of air is equal to 0. Here, if my entire voids, this is voids, whereas this is volume of voids. Okay, if my entire volume of voids is volume of air and volume of water, right? If my entire soil is dry, which means my volume of water is equal to 0, the entire volume will be equal to volume of voids will be air voids, then this will be called as dry soil. Instead, if my volume of voids is entirely filled with volume of water, then it will be denoted as VW, and this is VS, and this is called as fully saturated soil. Okay, and if it is partially filled with water and partially filled with soil and air, then it is called as partially saturated soil. Next, why we are reading this soil mechanics? In order to ensure that we have to have a safe and stable foundation, because the entire structure's weight is going to be transmitted into the soil. So we need to be very confined about this. And in order to know about the slope and stability, we need to study about soil mechanics, and to design a retaining structure and to implement a soil implementation techniques. If my soil is not able to, in our world there is entirely different kinds of soils we are present, which one can take more amount of load and one another cannot able to bear even a small amount of load. But we need to construct, we are in a situation to construct a building in that place. So I need to make that place an efficient place which can transfer my load. So that I need to make a foundation which need to be transmitted from superstructure to this substructure. For that analysis and all, I need to know about soil mechanics. And for designing of underground structures, bunkers and silos, also I need to know about soil mechanics. And applications of soil mechanics, like I can analyze like retaining walls, soil structures, slopes, stability. Along with I need to know about the structures, designs, tunnels, and deep foundations, pavement designs, and liquefaction factors and all I can be able to know from soil mechanics. And basic terms, this is a term which was the Void's ratio, porosity, and degree of saturation. These are the terms which will be related to our problems, which will be dealing with the further slides. First, initially, I would like to suggest that these formulas are the most important formulas, which is the basics of soil mechanics, so that even if you are trying to solve a single problem, you need to understand and know this problem that we are what it is. Like I would like to start from Void's ratio, whereas Void's ratio is represented as E. Void's ratio is represented as E. Here, and this Void's ratio is volume of soil and volume of voids. It is a ratio between volume of voids and volume of solid particles. In the entire volume, we will be having volume of solids and volume of voids. This is entire volume. If my ratio is between volume of voids and volume of solids, then it is called as Void's ratio. If instead of denoting this volume of solids, if I am considering an entire volume, then it is called as porosity. It is represented as En. This is in the terms of percentage. Void's ratio is always expressed in decimal, whereas porosity is expressed in percentage. It can be, Void's ratio can be greater than 1, but porosity cannot be greater than 100%. Okay. And coming to water content, it is the ratio between weight of the water divided by weight of the solids. And this is voids and porosity. Voids in the sense, if I am having, I am comparing it with my solid particles, not with the entire volume. If my porosity in the sense, I am comparing the voids with the entire volume of the soil particles. Then coming to degree of saturation, we will be having two types of voids, which is water void and air void, which is voids will be water voids along with that air void. Okay. If my entire void is based is water void, then it is called as degree of saturation. If my voids are represented in the terms of water, then it is SR. If my for dry soil, SR value is equal to 0, and for wet soil or else fully saturated soil, my SR value is equal to 1. So that my percentage can be 0 to 1. And for specific gravity is a ratio between unit weight of solids and unit weight of water. And then density index is the compactness index, whereas here the relativity index is this is also can be called as relative density or else density index. It is represented as ID. We will be comparing its Void's ratio when it is fully compacted or is fully loose in condition. It is Emax minus E divided by Emax minus E minimum, where this E is called as Void's ratio in its natural state, and E maximum, which means if I am pouring a soil into a container in a loose manner, there will be more amount of voids in that present. That state is called as E max. E maximum in the sense voids in the loosest state. If I am compacting the soil into a container layer by layer, my voids will be reduced and the voids will be filled with soil particles. Then it will be in the densest state. At the densest state, E will be considering E minimum. Okay. Next, according to the relative density or else density index, soil can be classified as very loose soil, medium dense soil, and very dense soil. If my formula is ID, right? I would like to start with ID, whereas ID in the sense as relative density or as density index, E max minus E divided by E max minus E minimum. Here, if my ID value is between 0 to 15, then it is called as very loose soil. If it is 15 to 35, it is called as loose soil, and it is 35 to 65, it is called as medium dense, and if it is 65 to 85, then it is called as dense soil, and if it is greater than 85, then it is called as very dense soil. And these are the interrelationship which we will be using for to solving problems. First, we will be having some formulas related to voids ratio and porosity along with the degree of saturation. Then we will be having porosity with weight, and then we will be having with unit weight, which is dry unit weight or else bulk unit weight or saturated unit weight. This formula can be converted into density also, which is dry density, wet density or a saturated density along with the bulk density also. I would like to first start with the first formula, which is interrelationship between voids ratio and E, which is where E is equal to, first formula is E is equal to, can you please note down that these are the most important formulas. These formulas will be used to solve these problems. Okay, like E is equal to N divided by N minus 1. And this can also be written in terms of porosity, which is N is equal to E divided by 1 plus E. And second formula we will be discussing with the volume, which is E is equal to volume into GS, which is G in the G S into gamma W divided by WS in terms minus 1. And the next one is SRE is equal to W into G. This is the most important formula where we can able to solve many numbers of problems. Okay, SRE is equal to WG, and then this is what I explained in the above itself, and then we will be having N is equal to 1 minus WS divided by GS gamma W into 1 by volume. And then we will be having dry density in the sense gamma D is equal to gamma bulk divided by 1 plus W, whereas this is unit weight, dry unit weight. Gamma D is called as dry unit weight, and then this can also be represented in terms of GS gamma W divided by 1 plus E. And then if it is a gamma, this is for gamma dry density, and if my soil is gamma saturated, if it is gamma sat is equal to G plus SRE into gamma W divided by 1 plus E. If my SR value is equal to 1, which is it is fully saturated, then gamma sat for fully saturated soil, or it is a submerged soil, it is G plus E divided by gamma W divided by 1 plus E. If my soil is fully dry, my SR value will turns to 0, then my gamma dry soil will be G gamma W, this 1 divided by 1 plus E. This is what represented here, G gamma W divided by 1 plus E. If my SR value is equal to 0. Let us solve some gate problems related to what we have studied today. First, soil particles. This question has been asked in GATE 2024 Sit 1 session. Consider the statement. We are going to compare two statements, which is first one is soil particles formed by mechanical weathering and close to the origin are generally subrounded. They are saying that soil particles are formed by mechanical weathering. Okay, it is by mechanical weathering. Mechanical weathering in the sense it is being splitted into two halves, and then they are close to their origin, which means they are residing at their parent rock itself, which means they are not, we have splitted the particles, and this particle, if my particles is bigger, due to physical weathering, it is broken into two particles. It may be of any size or shape. If it remains in the same place, this shape won't be changing. If it transmits from one place to another, then it will be in an order. It will be going from this part to this part and this part. Then only it will be changed into. Then only it can able to change its shape. So that first it won't be a subround particle. Second one, the activity of the clay physically ignifies its swell potential. If we are having a soil particle, if I'm it is a clay particle. If I'm giving water content into it, then only if I'm entering into the water with the absorption capacity, it tends to bulk the particle, which is swelling. Then this is called as activity. This activity of the clay signifies its swell potential. So that this Q is correct. We will be having P is false and Q is true. Yeah, here the last option is P is false and Q is true, and this is the correct one. Let us discuss about the second great question, which is the specific gravity of soil is 2.60. Specific gravity can be denoted as G. G is 2.60. G can be represented as 2.60, and then we will be having degree of saturation SR is equal to 0.5, and water content is 15%, which can be written as 0.15. We need to find Voigt's ratio. Voigt's ratio is E. Here they have given G, SR, W and E. We need to find E content, which is we can solve from this formula. SRE is equal to WG. Here they have given SR value, W value and G value, except E we can write WG divided by SR. From this we can able to solve the problem, which is W in the sense the water content, which is 0.15, and G is specific gravity 2.60 divided by and SR value is 0.5. You will be getting the answer to this. Okay, here the answer is 0.78. Have you got the answer? Yeah, fine. Next, we will be speaking about the soil, which is alkaline soil. Alkaline soil are mainly due to wind deposits, and this wind deposit soil are called as alkaline soil. If my soil resides at my plant, it's my parent rock itself, then it is called as residual soil. If it resides at my parent rock itself, then it is called as residual soil. If it is transported by wind, then it is called as alkaline soil. If my deposits is by gravity deposit, it may be a colluvial soil or gravitational tilt. If it is water deposit, which means in the form of river, then it will be alluvial soil. Here the answer question they have asked is alkaline soil, which is wind deposit. Next question is based on a normally consolidated soil. This is a group 1 and group 2 soil, which we similarly which we are studying in the match. Like normally consolidated soil, here consolidation ratio will be equal to 1, so that we will be having 1S. Then quick clay in the sense its sensitivity is more, then it will be having a sensitivity of greater than 16, which is 2P. Here 1S and 2P, 1S 2p. We will be having 1s in both the options, 2p in only one option, so this is our option. So we can discuss with other questions also, which is sand in critical state will be having a dilation angle, sand will be having a dilation angle of 0, and clay of high plasticity will be having a liquid limit of 50%. And the option is A. Next question, a clayey soil has a moisture content of 18%, a specific gravity of soil solids of 2.74, and the degree of saturation is 65%. The soil soaks up to water during a rain event, and the degree of saturation increases to 85.2%. Here, the change of the volume is during the soil soaking is negligible. The new moisture content of the soil will be, what we are saying, they have given us moisture content, initial moisture content, which is W1 as 0.18%, and the specific gravity G as 2.74, and degree of saturation, which is my SR value is 65%, which can be written as 0.65, and after this is an initial soil condition. After this, the soil content due to the rain condition, here SR value is converted into 0.85, but the volume remains same. Here they are asking what is the new moisture content, what is W2. From this we will be using the equation, which is SRE is equal to WG. From this equation we will be identifying this E. After finding this E value, we will be substituting with the same SRE is equal to WG. Here my SR value will be 0.85. That's it. From this you can solve the answer. Okay, thank you. You just try to solve this question, which explained, and we will be discussing further questions and the further topics in the next session. Thank you.